to their races. We're looking at Fall 2020 Test 1, Part 2, where we're supposed to do Lewis structures and redox. We're doing the first part. So we're supposed to draw Lewis structures for species 1 and 2. I'm going to go rather quickly on that. 1A over here, H, C, H goes to C with 1H, HC, goes to C with no H's, goes to, I didn't read my own question very well, did I? There's only one H in there. 1H, 0H, 2H on the next C. Not going fast after all, huh? Triple bond, and we have an alcohol off of the COH. Don't forget, we need a Lewis structure, so all valence electrons must show. Species 3 for 1B, it's in blue. HC, triple C, C, no H's. Don't forget your lone pairs. Now we have, these are atoms. 1C is the CH2 here. And in the product, that's one F. The same atom in the product is 1F. And D, 1D is this oxygen. And 1G is one of those oxygens. It doesn't matter. It says star. I hope it explains stars. Yeah, note, only give the oxidation state for one oxygen atom, not the total. So pick an oxygen. They both have the same oxidation state. Trust me. Okay, and we can go old school or new school for species 2. Old school, your 141 knowledge, you know oxygen in its normal oxidation state is -2. There's 3 of them. Whatever chromium is, call X, and it's a neutral species, so you got to get 0 when you're done. X equals +6. Okay, and when you're done, X again plus Cl, there's -1 times 5 equals 0. It's a neutral species again. X is +5. So we're looking at, that's 1E. 1E +6 and 1G. Oh, not a highlighter anymore. That's not G, that's H. H is +5. So we call that reduction. So choices for 1I and J. Which atom became reduced is J, and so you're going to say atom 1E became reduced. 1E. And on your sheet, you would have to copy. Let's look for a good way to do it on our exam sheet. You would definitely write down everything. Everything I circle in green is going to be on your exam sheet. You got to have everything there. Got to have everything there. Now to quickly get through the oxidation states on your exam sheet, go 1, C, D, E, F, G, H. And I'm going to circle this when I'm done. We haven't done C, D, but we did E, it's +6. And we did H, it's +5. We're about to do C, D, F, and G. When we're done, I got to make sure this is all in a circle. Okay, so when we do oxidation states, we have to look at every bond an atom has. The choices for 3 oxidation states for a bond are you get a -1 when you're bonded to a less electronegative atom, like carbon bonded to hydrogen, -1 for that bond, and -1 for the same kind of bond here. You get a +1 for a bond to O. You get a 0 for a bond of the same electronegativity. So negative, negative, positive is -1 when you add them all up. 1C, -1. Let's go to the same atom, which is atom F. Here, you get a 0 for a bond to a same electronegativity. For each of the bonds to the more electronegative O, carbon gets a +1 oxidation state. +1, +1, +1. F is +3. We already established that this was a reduction. Let's put it in a different color. And atom 1C became 1F. And that's a reduction. Sorry, oxidation. What am I saying? It went up. Oxidation. The symbols are supposed to be in square brackets. So the atom that became oxidized was atom 1C. So 1C, which atom became oxidized? So my answers to 1I and J. I was 1C and J was 1E. These are on my answer page. I'm putting them in green circle. What else? I don't think D changed, going from D to G. D is the oxygen here. We didn't do it. This is a normal oxygen because it has 2 bonds to less electronegative atoms. It gets a minus for each one, -2. That's your normal oxygen oxidation state. Oxygen, when we're done either here or here, has 2 bonds to less electronegative atoms, still -2. So these are not hard points to get on your test, and I believe we have everything green circled is your answers. I don't need to see the symbols here and here. You've already answered those here. We didn't do which species is the oxidizing agent. That's 1L. And which species is the reducing agent, which is 1K. Well, look at what atom became reduced. Atom E, which was in species 2. This would not have become reduced, this atom, if species 1 was not present. Species 1 caused the reduction. You just write species 1 is the reducing agent. It tells you the 2 choices right there. You write species 1. And similarly, what atom became oxidized was C going to F. And where C, it's in species 1. That would not have happened if species 2 was not present. Species 2 is the oxidizing agent. L, species oxidizing agent. There you go. Circle it. It's part of the answers. 14 points in the can. And that is an end to the problem from Fall 2020 Test 1, Part 2, Question 1. And we'll leave it at that.
Okay. Thank you, Professor.
Did that cover all your concerns?
Yeah.